Welcome to ZoomInData, your go-to channel for in-depth data engineering, analytics, and modern cloud technology interview preparation. In this video, we dive deep into the top 25 performance optimization techniques in Microsoft Fabric interview questions for 2025. Perfect for data engineers, analysts, architects, and anyone preparing for Fabric Lakehouse, Warehouse, Spark, Power BI, or capacity management roles. We cover query optimization, compute and storage efficiency, Delta Lake techniques, V-order, Z-order, OPTIMIZE, caching, autoscaling, monitoring, direct lake, real-time workloads, cost-performance balance, and best practices, all explained in clear, interview-ready technical language to help you confidently ace your next interview. 1. What performance optimization techniques are used in Fabric? Fabric employs Delta Lake optimizations like V-order for write-time columnar efficiency and Z-order for data co-location on frequently filtered columns to accelerate reads. Automatic features include adaptive target file size, auto-compaction, and fast optimize to manage small files and maintain ideal Parquet layouts without manual intervention. Query-level enhancements leverage Catalyst Optimizer, adaptive query execution, and native execution engine for dynamic plan refinement and up to 5x faster Spark processing. Capacity autoscaling, result set caching, and direct lake mode ensure low latency analytics with minimal resource overhead across workloads. 2. How does Fabric optimize query performance? Automatic statistics collection and cost-based optimization guide efficient execution plans in warehouse and SQL endpoints. Predicate pushdown, column pruning, and data skipping minimize scanned data volumes on Delta, Parquet files. Result set caching persists frequent select outcomes for sub-second reuse in analytical scenarios. Direct Lake mode loads Delta tables directly into VertiPack memory, delivering import-like speeds without refresh cycles. 3. How does Fabric manage compute resources efficiently? Serverless autoscaling dynamically allocates vCores based on workload demand, bursting during peaks and minimizing idle costs. Smoothing spreads background operations over 24 hours to prevent throttling and stabilize utilization. High concurrency mode and dynamic executor allocation share Spark sessions across notebooks and jobs. Auto-tune automatically adjusts Spark configurations to minimize execution time without manual tuning. 4. How does Fabric optimize storage usage? Delta Lake compression, vacuum for dereferenced file cleanup, and time travel retention policies reduce OneLake footprint. Auto-compaction and adaptive target file size merge small files intelligently to maintain optimal 100 MB to 1 GB Parquet sizes. Shortcuts provide virtual access to external data, eliminating physical duplication across workspaces. V-order enhances columnar compression and row group distribution for denser, faster readable files. 5. How does Fabric handle caching? Result set caching in warehouse and SQL endpoints persists identical select results for rapid reuse. Spark caching, persist, stores intermediate data frames in memory or disk with configurable storage levels. Node-level file caching accelerates repeated Delta, Parquet, CSV reads in Spark pools. Direct Lake leverages in-memory VertiPack loading with temperature-based column paging for hot data. 6. How does Fabric optimize data ingestion performance? Fast copy and polybase loading enable high-throughput bulk transfers to Lakehouse, warehouse destinations. Incremental refresh in data flows and change data feed process only deltas, reducing volume and time. Optimize write balances file sizes during streaming, micro-batch writes to prevent small file proliferation. Parallel copy activities and staging options in pipelines maximize ingress concurrency. 7. How does Fabric optimize transformation workloads? Query folding in data flows pushes operations to sources, minimizing data movement and compute. Partitioned compute and modern evaluator parallelize complex, non-foldable transformations. Incremental patterns with watermarks and upserts avoid full recomputation in medallion layers. Autotune and native execution engine accelerates Spark-based ELT pipelines significantly. 8. How does Fabric optimize Spark jobs? Native execution engine offloads to VLOX C++ for 2 to 5x gains over JVM-based processing. Autotune iteratively tunes configurations like shuffle partitions and memory fractions. Dynamic allocation, fair scheduling, and high concurrency mode optimize executor utilization. Optimize with Z-order, V-order and auto-compaction maintain efficient delta layouts. 9. How does Fabric optimize SQL workloads? Automatic compaction preemption avoids conflicts between maintenance and user queries. Statistics-driven optimizer with adaptive execution refines plans for analytical patterns. Results set caching and materialized views pre-compute frequent aggregations. Partition elimination and data skipping leverage clustering for targeted scans. 10. How does Fabric manage workload concurrency? Autoscaling and workload smoothing handle spikes without persistent over-provisioning. High concurrency mode shares Spark applications across multiple notebooks, users. Throttling and priority queuing prevent overload in shared capacities. Isolated ingestion nodes in warehouse separate ETL from analytical queries. 11. How does Fabric detect performance bottlenecks? Monitoring Hub aggregates logs, durations, and resource metrics across experiences. Spark UI and Advisor APIS diagnose skew, spills, and suboptimal configurations. Query Insights views historical SQL executions with durations and plans. Capacity Metrics app identifies throttling, overload, and high consumption items. 12. How does Fabric support performance monitoring? Capacity Metrics app visualizes CU utilization, throttling, and autoscale events over time. Time Point Drill Down analyzes specific overload periods with operation breakdowns. Lineage views trace bottlenecks across pipelines, notebooks, and queries. Alerts notify on thresholds for proactive tuning and scaling. 13. How does Fabric optimize real-time analytics performance? Event streams enable in-flight transformations with windowing and low-latency routing. Direct Lake fallback minimizes delays in Power BI real-time dashboards. KQL databases autoscale for ingestion and query patterns in real-time intelligence. Structured streaming with checkpoints ensures efficient stateful processing. 14. How does Fabric handle large-scale analytics efficiently? Distributed Spark clusters with dynamic allocation process petabyte-scale datasets. Delta partitioning, clustering, and optimize enable skipping irrelevant files. Direct Lake loads massive delta tables directly into memory without import overhead. Capacity bursting and reserved instances support sustained high-volume workloads. 15. How does Fabric optimize resource allocation? Autoscale adds temporary CUs during peaks, charging only for usage. Dynamic executor allocation adjusts based on job demands within pool limits. Smoothing distributes background costs evenly to avoid SKU upgrades. Resource profiles pre-tune Spark for read, write, mixed workloads. 16. How does Fabric manage memory efficiently? Unified Spark Memory Manager dynamically shares execution and storage regions. Off-heap tungsten allocation reduces GC overhead in large transformations. Adaptive query execution coalesces partitions to prevent small task overhead. Direct Lake temperature-based paging prioritizes hot columns in VertiPack. 17. How does Fabric optimize joins and aggregations? Broadcast joins eliminate shuffles for small tables. Bucketed joins on clustered delta avoid them. Partial aggregations and AQE handle skew in group by operations. Z-order co-locates join keys. V-order accelerates columnar projections. Window functions leverage optimized over clause execution in Warehouse Engine. 18. How does Fabric manage indexing and partitioning? No manual indexes. Automatic clustering and statistics guide optimizer. Table partitioning enables elimination on filtered columns for faster scans. Z-order multi-column locality complements partitioning for complex predicates. V-order row group distribution enhances general read skipping. 19. How does Fabric optimize data movement? OneLake shortcuts enable zero-copy access across workspaces and external sources. Fast copy and staging accelerate bulk transfers without transformation overhead. Incremental loads via CDF and watermarks minimize transferred volumes. Polybase and binary copy optimize format, preserving migrations. 20. How does Fabric improve dashboard performance? Direct Lake mode delivers sub-second visuals without import refreshes. Aggregated gold layer tables and materialized views pre-compute metrics. Result caching serves repeated report queries instantly. Composite models blend Direct Lake with import for optimal visuals. 21. How does Fabric optimize cost-performance balance? Pay for use on active time. No charges during idle periods over 2 hours. Incremental processing and autoscaling reduce unnecessary compute. SKU estimator and metrics app guide right-sizing to avoid over-provisioning. Reserved capacities offer predictable pricing for steady workloads. 22. How does Fabric ensure predictable performance? Smoothing and throttling stabilize interactive operations during bursts. Reserved instances guarantee baseline resources without sharing variability. Maintenance automation, auto-compaction, statistics, prevents degradation. Monitoring alerts enable proactive tuning for consistent SLAs. 23. How does Fabric optimize cross-workload queries? Unified OneLake access joins Lakehouse, Warehouse, and mirrored data seamlessly. Direct Lake fallback executes complex DAX on SQL endpoints when needed. Cross-database TSQL unifies analytics across Fabric items. Semantic Link evaluates power by measures in notebooks for hybrid insights. 24. How does Fabric handle performance scaling? Capacity autoscaling bursts CUs temporarily. Manual SKU upgrades for sustained growth. Spark custom pools configure node sizes and dynamic allocation limits. Throughput units in event streams scale real-time ingestion independently. bursting and optimistic admission exceed base cores during peaks. 25. What are best practices for performance optimization? Implement medallion architecture with incremental processing, partitioning, and regular optimize (ZORDER) V-order on Delta tables. Monitor via Capacity Metrics app and hub. Enable auto-tune, native execution, and result caching for automatic gains. Use Direct Lake for Power BI. Apply query folding, early filtering, and avoid fallbacks through healthy Delta layouts. Right-size capacities with SKU estimator, leverage autoscaling, and orchestrate maintenance via pipelines for sustained efficiency. Thank you for watching. If this video helps you prepare for your Microsoft Fabric interview, please give it a thumbs up and share it with your network. Don't forget to subscribe to ZoomInData and hit the bell icon for more in-depth data engineering, analytics, and cloud technology interview prep videos every week. Drop your questions or topic requests in the comments. Let's zoom in on your success together.